Hello, hi everyone. This is Eric from MathWallet. I'm the CTO of MathWallet, and today I'm going to share you some methods to connect your Dapp to the common crypto wallet, including MathWallet and Metamask. So first, let's start from some basic knowledge point. First one is about injection. So how is a Dapp to kind working together with a crypto wallet? Normally, the crypto wallet will inject kind of a JS object in the browser, and you can use that to directly use in your Dapp, and it will automatically connect to the crypto wallet. So for example, if you open the Chrome console and you type Ethereum, you will see there are several values already there. For example, you will find there's a MathWallet value, which is true, which means currently the MathWallet is injected successfully. And also from this object, you can get some other values that is useful to you. For example, the current injected wallet address, or etc. We will talk some of the parameters in the later of this session. Okay, and the second basics knowledge is EasSuggest vs Web3 So there are two libraries that wraps Ethereum JSON RPC into our more readable and user-friendly JS libraries. Basically, they are doing the same things, but I think recently there are more developers will use the EasSuggest, which is more easy to read. But basically they are very similar, and you can choose both of them. And I provide two links in the below, and you can check their details. They are very small difference. Yeah, and the next basics is we all know we are in a multi-chain world. Other than Ethereum, you have the other EVM compatible public chains, including BNB Chain, right? So how to connect your Dapp to our BNB chain instead of Ethereum? So one thing very important here is in the injected Ethereum object, you will see there are two parameters. One is the chain ID. Okay, it's a hex format, and another is network version. So both of them are point to the same value, which is the chain ID. And if you visit the website called Chain List, and you can search for different EVM chains, and you will find, for example, for the BNB chain, which is also called BSC, right? Its chain ID is 56. Okay, so it is same to the network version, and also the hex format chain ID in the object. So based on these values, you can know which is the current chain that the user's crypto wallet is using. And if it is not matched, you can pop up some messages and ask the user to switch their environment. So next, I will separate to 4 different environments, which I will recommend one wallet connection libraries, which is the best practice for that platform. So we separate to 2 different types on the platform. If your Dapp is on desktop or it is on mobile. And then we separate to if your Dapp is a web Dapp or it is a native Dapp. So first, let's see a desktop environment, and you are developing a web Dapp. For this environment, the best practice is the block native onboard libraries. And you can see it will be support multiple wallet in the same time, and it will automatically find out what the current user is using the crypto wallet. So I will also list the pros and the cons here. The pros for the onboard component is it supports all kinds of protocols, especially it supports hardware wallet, including Ledger and Trezor. So this is it's very good point, and it automatically matches the inject wallet. For example, if the user is using MathWallet, it will automatically show MathWallet in the interface. It cons is it only supports its wallets that's already inside the component. For example, for some wallet, it provides compatible with Metamask, but for these libraries, it cannot be used. It has to be Metamask. It needs to be exactly the same. So this is the first environment. Let's move on to the next environment. So if you your user is in a mobile environment and you are develop a web app, normally in this case, user will open their web app in the called Wallet Web3 browser environment. So in this case, the recommended library is the Web3 model. So for this one, it has very similar function. It supports all kinds of protocols. And for the developer side, you just need the same code. You do not need to do the compatible with all kinds of wallets. And it provides the better UX inside the wallet Web3 browsers. So this component is also used by many dApps, including like Uniswap, etc. So it's very commonly used. But its cons is it do not support hardware wallet. So if you want your user need to use Ledger, etc., you need to do some customization to support that. Okay, and next environment is if you are developing in a desktop environment and you are a native Dapp. This situation normally, if you are doing like a TV Dapp and you need user to sign crypto transactions and interact with your TV Dapp. In this environment, the best practice is Wallet Connect. Because it shows a QR code and the user can use their mobile phone to scan the QR code and to sign transaction. So the pros for this library is it also provides multiple wallet support in the same code, and it supports QR code. This is very important in this kind of situation. But the cons for this library is it do not have callback functions, which means user need to switch the app manually. This will be not a big issue for like the TV, but if you are a native app on the other platform, you find after the user signed the transaction in the wallet, it will not go back to your game automatically because there's no callback functions. So which makes user sometimes confusing because they're completely signed and there's no confirmations to tell the user what they need to do next step. Okay, and so the last environment we'll talk about is in a mobile environment, and you are a native Dapp. What we see, this is normally used by our native game Dapp. So in this environment, we would recommend the simple wallet libraries, which currently already supported by MathWallet. So what it did is, you can see in the left screen, it is a native app. It can be a game or some others. And if you click the actions, it will pop up the MathWallet app and pop up the login or sign transaction windows. And after user complete the sign, it will automatically return back to the native app. So the pro for this is it already have the callback supported, and it also support the deep link format, which makes you very easy. For your native app, you just need to compose a deep link, and it will automatically do the jump and to the return actions. Also for MathWallet, we think there are more and more GameFis coming in this area. So we have a Math grant program, which to support this kind of library. If any team is developers this kind of library, we would provide some grants. And last is the con for this library. So it's kind of like a new protocol for GameFi. So it's in the early stage. There will be still more and more development in this library. Okay, so last is after you complete your Dapp, you can use these two URLs to submit your Dapp, both to MathWallet and to BNB project, and we will have more exposure for your Dapp application to more users. Yeah, so that's our quick sharing for today. Thanks everyone for the listening, and hope you have a great hackathon experience. Thank you.